Hello dear students! In this capsule, we'll talk about acid-base reactions and his relationship with a very common disease in the mouth, even our mouth. Let's start with the basic concept. A solution is a homogeneous mixture of two or more pure substances. This mixture occurs in molecular or ionic level. A very simple example is a juice. To produce a solution, a process called solvation must occur. This is the interaction of the solvent, defined as the compound present in the greatest amount in the solution, with the solute, the compound present in the smallest amount. The solvent dissolves the solute. In this case, the juice, the solvent is water. The solute is the juice powder. All solvents can be classified according to his polarity. Polarity is a property of chemical compounds that describes the separation between his atoms. A polar solvent have no equal electric charge in their molecules. This forms electric poles which attracts ions with opposite charge. The most common polar solvent is water. Water presents a positive charge, hydrogen atoms, and negative charge, oxygen. This allows to attract the opposite atoms in their respective charge, like this example, salt in water, with sodium is attracted by oxygen and chlorine is attracted by hydrogen, breaking up the ionic bond of the sodium chloride. This process is known as the name of hydration. As you know, an acid-base reaction is a chemical reaction between an acid, a chemical compound that donates protons of hydrogen, and a base, the chemical compound that accepts this proton. All this process occurs, in many cases, in presence of water. Classic example of acid-base reaction, the formation of sodium chloride, salt. Well, why it is important to know acid-base reaction in dentistry? Because the etiology of dental caries is really an acid-base reaction. Dental caries is like periodontal disease, the most prevalent disease in the mouth. His etiopathogenesis is very complex and involves many factors, like the host, our mouth, our defensive system, our diet, our hygienic habits, etc. The dental biofilm, time, and saliva. Saliva is a clear lubricating fluid based in water, which means it's a polar solvent that contains enzymes, electrolytes, mucin, and another substance. Saliva helps to swallow the food and also is the beginning of the food digestion because saliva contains an enzyme named amylase. Also, saliva neutralizes acids and aids to enamel caramelization. This picture shows the dental biofilm. A biofilm is formed with multiple types of bacteria interacts between any surface and between themselves. This interaction is direct and indirect. Bacteria can interact with other bacteria and produce proteins that help to other bacteria to stay. This biofilm can produce a healthy state or a diseased state, depending on the host conditions, just like many diseases. In the case of carcinogenic dental biofilm, certain types of bacteria, especially Streptococcus mutans, use sugars to produce energy through the process of glycolysis. Glycolysis produces lactic acid. This study aimed to measure the potential of the lactic acid attack produced by dental biofilm. Images A, B, C, and D shows attacks by lactic acid used in chemistry at different concentrations. Image F shows the lactic acid produced by an oral biofilm culture. Comparing image D with image F, we can see that the acid attack by a biofilm, or produced by the biofilm, is quite strong. Acid, lactic acid, attacks the dental enamel, which is composed of a minimal complex named hydroxyapatite. It's a simple acid-base reaction. Lactic acid more hydroxyapatite forms in presence of water calcium carbonate, calcium and phosphate ions, and water. But our mouth can defend of these acid attacks, and saliva is a very important to caution this attack. This is a De Stefan curve that shows how after a minute of a sucrose rinse, the pH curve in the mouth is inverted. The pH increases and the dental element is remineralized. Saliva is a buffer in the mouth and allows to recover the normal pH here. This is because saliva contains protein buffers, carbonic buffers, and phosphate buffers.